Module 2, Lesson 9's objective is to go from concrete to abstract. They will measure lengths of string using measurement tools, then represent length with tape diagrams to represent and compare the lengths. In Lesson 4, we learn that meter tapes can be used when measuring round objects or when measuring things that are not straight. So, on number 1, the students are to find the measurement around 3 objects in your house and then complete the chart below. If I was going to be trying to find something that was easy to find in my house that was round, I might find a ball. So I'm going to write a ball here. I might also find an orange. And another round thing that I might find would be a can. You know, like a can from the pantry. The next thing you'll do is have the student make an estimate using centimeters and write down their guess, their reasonable guess. That's what an estimate is, a reasonable guess on how many centimeters around the ball is, or how many centimeters around the can is, and also the orange. Then after they make their estimate, not before, after, have the students take their meter tape and measure around the ball. That is also called the circumference of the ball. Have them measure and then write down the actual number of centimeters the ball is. And then have them do the same for the orange and the can. If their estimates were not accurate, they should not change their numbers. Again, those were only estimates and they don't have to be right. So they just need to be reasonable. We know that a meter tape is divided into centimeters. We also know that there are 100 centimeters in a meter. And so the meter tape should go to 100. Anything over 100 centimeters is a meter or more. On letter A, what is the difference between the greatest and shortest measurements? Whatever number has the largest number of centimeters, we'll write it here. I'll write the word largest here. And whichever one has the smallest goes here. If we're looking for the difference, we're comparing them, and a difference means the answer to a subtraction problem. So we'll take those two numbers and subtract them from one another to get the answer. That is the difference in centimeters and should be recorded on this line. Now we're going to take a tape diagram comparing the estimated measurements. A tape diagram simply is a diagram that shows a number value and compares them. So, for instance, if I was using a ping pong ball, my tape diagram might look like this. And then the number that I estimated would go above it. And then I think that my can would be the next largest. So I will go like this for my can. And then put the number above it or even inside of the rectangle. And lastly, I think maybe my orange is even longer. Then after doing this, I will label these. So I remember that this was my ping pong ball. I'll put B for ball. And that this was my can and this was my orange. Anyway, then I will use the numbers to show the numbers that I estimated. They should go from small to big based on the numbers that I estimated. Then in item C, we'll draw another tape diagram to compare the actual measurements. So maybe I was right. My ball was the smallest, but maybe my estimated number wasn't quite right. My new number will go above this rectangle or inside of it. And maybe my orange ended up being a smaller amount than my can. I will put that there with the new number, the correct number, and that my can ended up being a larger amount. Maybe it was one of those super big cans. And so now I'll draw my new tape diagram, but this time using the accurate actual measurements in centimeters. Again, don't forget to label your rectangles so that your teacher knows which line represents which item you measured. Now you don't have to use a ball, an orange, and a can. You can use any round objects that you find in your home. Have fun measuring!